Hey pre-calc students, welcome to the lesson for today. This is Ms. Carranza, and today I'm going to show you how to complete the square. Completing the square is a method of rewriting or converting a parabola in standard form into a parabola in vertex form. Now remember, you can write the equation of a parabola in both ways and still have the same exact parabola. So the key here, guys, is that after you're done rewriting the equation, it should still be the same parabola. So even though you're supposed to be doing this without a calculator, you can check your answers while you're doing your homework by graphing both of the equations, the original one that I give you and the one that you found. So keep that in mind. All right, now standard form has three important numbers, okay, or coefficients that you're looking at. The A term is the one that is next to your quadratic term. So that one we call the quadratic coefficient. Now, so completing the square has a little bit of a different strategy if A equals 1 and if it doesn't equal 1. So again, A is the coefficient of your quadratic term. So let's do a few first. So there's your quadratic term, okay? The ax squared. Let's do a few examples first without a calculator of how to rewrite something in standard form, a quadratic in standard form, to a quadratic in vertex form. These both are going to have a leading coefficient of 1, positive 1. I am going to label all the coefficients A, B, and C for the purposes of being able to follow the steps. So if you read the steps, actually let's do this. Why don't you go ahead and pause the video and read the steps. Push play when you're ready. If you notice, the steps are always referring to either the linear term, the constant term, etc. So that's why I label my coefficients as A, B, and C. All right. I don't know if you noticed, but in vertex form, there's a parentheses with a squared on the outside. The terms in the parentheses are a binomial. So if you have a binomial squared, you're telling me that there's two of the same one. So if you're having a hard time visualizing that, here we go. In vertex form, you have a binomial to the quantity exponent 2. That means you have two of the same binomials. So essentially what we're going to do is we're going to factor these trinomials and get two of the same binomials so that we can say that we have that binomial squared. However, the trinomial that I've given you, first of all, can't be factored, let alone be factored into two of the same binomials. So the number that kind of is in our way of being able to factor it that way is the C. So that's why step 1 says, push your constant term off to the side. Leave enough room for one number to fit in between your linear term and your constant term. Now, we're going to work a little bit of magic. We are going to use half of B and square it to create a trinomial that could be factored into two of the same binomials. So I'm going to take half of B. So remember, the B term is the 12. Half of B and square it. So half of 12 is 6, and 6 squared is 36. So that's half of B squared. Now take a look. This trinomial can factor into two of the same binomials. What numbers multiply to 36 but add to 12? 6 and 6. So look, we can write that as a quantity squared. However, as soon as I added the 36, I changed the value of the parabola in the equation. the original equation didn't have a plus 36. So what I'm going to do is, staying within the rules of algebra, I added 36 for the purposes of being able to factor the trinomial into two of the same binomials. I have to kind of undo the 36. So if I added 36, I'm also going to subtract 36. And if I simplify these guys, so negative 11 minus 36, it's negative 47. And keep bringing it down. This parabola, so this parabola in vertex form, is the same exact parabola as the one in standard form of 1x squared plus 12x minus 11. You don't believe me? Put it in your calculator. Type the standard form, the one they gave you, x squared plus 12x minus 11 into your y1. Plug in the x plus 6 quantity squared minus 47 into your y2, and when you graph them, you'll see that they're the exact same parabola. So it is very important that when you take half of b and square it, you essentially undo that step off to the right. Okay, so I added 36 for the purposes of me getting a trinomial that could be factored into two of the same binomials, but I don't want to change the value of the equation. When you add 36 to something, you're changing it. So I subtracted 36 as well, because what's 36 minus 36? 0. So I essentially didn't change the equation. I just changed what it looked like to get what I wanted. Okay, let's do another example. So don't panic if that one didn't make sense too much, okay? Practice makes better. This trinomial cannot be factored, let alone factored into two of the same binomials. So what I'm going to do is I'm going to create a new trinomial, keeping the first two terms the same and pushing the constant term off to the side. I'm going to fill in the void, or fill in the space, by taking half of b, so half of b, and squaring it. Okay, well, half of b is negative, so half of negative 2 is negative 1, and negative 1 squared is positive 1. Positive 1, okay? So I'm going to go ahead and add 1. But if I add 1 to the whole equation, I've changed the value. So I have to kind of off-balance that by subtracting 1. If I wanted to simplify right now, I should be able to get the original equation back, because the ones would cancel. So that's the goal, is you're not allowed to change the value of your equation. You're only allowed to change what it looks like. So if you add something to it, you also have to subtract it to get it back to its original value. So if you're wondering, okay, if we're going to add 1 and subtract 1, then why the heck did we write it? Because we've now created a trinomial that can be factored into two of the same binomials, and you can combine these two terms. So let's do that. What numbers multiply to positive 1 but add to negative 2? Negative 1 and negative 1. And then 7 minus 1 is 6. Check it out. We've got a parabola written in vertex form that if I were to graph it would give me the exact same parabola as the original. But unfortunately, the leading coefficient will not always be 1. So there's an extra step for those. Okay, pause for a second and read the directions of what to do if the leading coefficient is not 1. Push play when you're ready. Okay, so according to the steps, I still push the constant term off to the side. Now I'm going to concentrate on creating a new trinomial here. But before I take half of b and square it, I need to obtain a leading coefficient of positive 1. So I'm going to go ahead and divide just the first two terms. That's important. Just the first two terms by negative 1. So the minus 8 is still there. It's just off to the side. And I'm going to create a quadratic trinomial that now begins with a 1. So I can follow the steps that I learned previously. Okay. Now I can take half of b and square it. So again, the b, you can take half of it and square it as long as your leading coefficient is 1, okay? It was negative 1, so I had to factor it out, and then I could take half of b and square it. Okay, so that gives you positive 9. Now in the previous examples, if we added 9, we had to subtract 9, right? Yes, but this is not a 9. It's not a positive 9. You see how we factored out the negative 1? So if I were to distribute that, negative 1 times 9 is negative 9. How do you undo a negative 9? You add 9. So remember, you're trying to keep the balance. You want to make sure that if you change the equation by adding something, you also subtract it to keep it off balance. And I'm almost done. Keep the negative 1, factor your new quadratic trinomial, and simplify or combine the last two terms. So x squared minus 9x plus 9 factors to x minus 3 and x minus 3. Negative 8 plus 9 is 1. And then finally, write it in vertex form. You don't have to put the negative 1 in front. You can just put the negative symbol. So again, when you're doing these problems and the leading coefficient is not a 1, you are going to need to factor out the value of a to obtain a leading coefficient of 1. But you only divide the first two terms because the constant term is already pushed to the side. So remember, we divided by 5, we factored out a 5, now I have a leading coefficient of 1. And now I can take half of b and square it. So remember, don't take half of b and square it until your leading coefficient is a 1. I don't want to forget the minus 10. Oh my goodness. Okay, so how do we fill in this number? Half of b, so this is my new b, which is 4. So half of b and square it. So half of 4 is 2, and 2 times 2 is 4. Now, it looks like I added 4. So how do you off-balance adding 4? Subtract 4. Normally that would be the case, but this isn't just a 4. This is a 20 because of the 5 out in front. 5 times 4 is 20. How do you off-balance a positive 20? Subtract 20. Okay, so 5 times 4 is 20. All right, what do we do next? Bring down the 5. Factor your quadratic trinomial. So factor your quadratic trinomial. It will always factor into two of the same binomials. How come that'll always happen? Because we forced it to. By taking half of b and squaring it, we changed it into a factorable trinomial that will always give you two of the same binomials. And again, you can check your answer by graphing the original equation and the original equation in standard form and the equation in vertex form, and you should get the same parabola. All right, guys, as always, if you need any extra help, send me a message on Remind. Have a good day.